As 2022 wraps up, I wanted not to bring you a conversation with one guest, but rather look back at the year, at some of the conversations I've had, take clips and excerpts of all the conversations I've had, and try to bring you some of those that I find the most interesting and insightful. Whether you're just new to the podcast or maybe you skipped a few episodes, hopefully this will bring value to you. I think I've had many long conversations. It's hard to keep up with all of them. And I know there are interesting tidbits here and there that are deep within these conversations. I'd like to take the end of 2022 as an opportunity to bring some of these highlights to you. Before we get started with the interview, I want to thank today's sponsor, which is OpenCage. If you work with addresses and location data, chances are you're going to need a geocoder. Geocoding is the act of translating coordinates, so think latitude and longitude, that are created by smartphones and tracking devices into human understandable places, like street names and place names, or the other way around. So OpenCage provides a geocoding API, which is built on top of open data sources, one of them being OpenStreetMap. This allows them to provide their geocoding API at a pretty low cost, as well as having pretty loose licensing terms compared to proprietary platforms. So you can do things like store the data as long as you want, display it on any map, and use it publicly or behind a firewall. So if it's built on top of open data sources, you may be wondering, why wouldn't you be able to do it yourself? Well, you can totally make your own geocoder, but what OpenCage provides is just a simple API that works and that is reliable. Basically, they take care of all the maintenance. For example, OpenStreetMap alone gets edited 4 to 5 million times a day. On top of that, OpenCage provides information like local time zones, what currency people use, and which phone code is used. Because OpenCage is based around open data, that means their pricing is also pretty affordable. And they have a pretty generous free trial that I encourage you to go take a look, especially if you're just playing around or are doing a personal project. Finally, which is pretty close to my heart, they've been long supporters of the open source community and just geospatial community as a whole. So if this sounds interesting, you can go to the link in the description to see more about them. I want to kick off this 2022 episode with one of the highlights of this year for me, which was a long conversation with Steve Coast, the founder of OpenStreetMap, one of the biggest open source projects in the world and probably the biggest one related to mapping. We talked about many things with Steve about the beginnings of OpenStreetMap, how it started, why he thinks it worked, but one of the clips I wanted to bring to you today is his thoughts about what might be the end of OpenStreetMap and looking forward.
The next thing that's going to blow up OSM is going to be one of two things. It's going to be automation, right? So we talked about earlier, Tesla could just make a map in a day with the right software, and they could make a great map. And by the way, that's really interesting because OSM, you can think of this vast, complicated network, right? This artifact that we're trying to keep perfect all the time. But instead, if you think of just, we're going to make a map every day, and then tomorrow we'll make another map, and then tomorrow we'll make another map after that, right? And you're just throwing it away every time. And the software every day is just collecting all the data signals and turning it into a map. You completely get around all the modern problems of map making, which is that you have this artifact that you're trying to keep perfect, like spinning a plate on a stick, right? You've got all these plates on sticks that you're trying to keep spinning. And if you don't keep them all spinning, one of them's going to crash and fall over, maybe it'll knock the other plate over. That's what it's like trying to maintain a map, not just OSM, in a lot of commercial systems as well, right? So the two things that are going to blow it up are automation or some sort of distributed blockchain-ish like system for this map data, such that it's not centralized. But that's still sort of predicated upon the idea that you're going to have a bunch of volunteers going around making this data or something. Or it could look like something like Daylight, right? So Facebook/Meta's distribution of OSM, where they take OSM, clean it up, maybe add some data, and then they have a known distribution, a bit like a Linux distribution of Ubuntu, right? Where no longer are you using OSM, like nobody downloads the Linux kernel, right? I mean, some people do, but most people don't download the Linux kernel. It's running on your phone, on your Android device. It's part of Ubuntu, right? But you're paying for some downstream service, right? So you could imagine a world where you take OSM, fix it, for some value of fix, add the things that OSM misses, which is for some use cases a vast amount of stuff, and then you ship that as a product, which is exactly what Facebook did, right? And it's what Microsoft would have called in the 90s embrace, extend, and extinguish, right? So to me, the interesting things, like, you could put an enormous amount of effort into trying to fix OSM's problems or do this stuff. And it is possible, and people should do that. And I'm happy to help, right, where I can. But it's a lot of uphill work trying to convince a committee of something that's obvious that no one wants to do because they only bear the downside, right? It's not inherent in committees or those people. It's like, it's the incentives, right? If you work at BMW, you're going to make gasoline cars. It's just how it works, right? Convincing you to go and make electric cars is going to be exceptionally difficult. And when you make electric cars, they're going to look retarded, like the i3 or the i8 or whatever. And even the latest BMW electric cars, they have to put some stupid big blue stripe down the side of it, like to say it's an electric car, right? You can go and try and convince BMW to make electric cars, or you can start Tesla or something, or you could go work at Tesla, right? Which one is easier? Which one are you going to be fighting less, right? Which one are you going to make more progress? Well, that's pretty simple, right? And then the automation piece is super interesting. How do you just automatically make maps? And that doesn't mean that humans aren't going to make maps. It doesn't mean that OpenStreetMap will cease to exist. Britannica still exists, believe it or not. It's like, but it's these new ways of thinking, new ways of doing things.
Mm-hmm. I've talked to many people this year, and one of my favorite conversations is with Barbara Ryan. She was instrumental in the 2008 Landsat policy change that made the Landsat imagery go from paid to open and freely available for anybody to use. This is probably one of the biggest policy changes in Earth observation that enabled a lot of the industry we see today. Let's go on the Landsat story. Can you help me understand what the situation was like before 2008?
Yeah, sure. And at least for Landsat, that date would date back to about 1972, even before, but the first satellite was launched in 1972. And the relationship was such that NASA, the U.S. space agency, would build and launch the satellites and operate them. But then would often turn it over to an operational organization, and in this case, the U.S. Geological Survey, to handle the data that would come back down from the satellites. And that's not atypical of the relationship that, say, NASA would have with NOAA, the National Oceanographic and Atmospheric Administration, for the weather satellites. So one entity may build and launch them, another entity may operate them. Now, you can imagine back in 1972, and maybe to this day, NASA has orders of magnitude more resources than, say, the Geological Survey. So at the time, the Geological Survey argued that they didn't have the resources to distribute the data or those Landsat scenes for free. So they would either need additional money from Congress to do it, or they would have to sell the data. And that's the scenario that we got into, was the NASA built and launched the satellites. The USGS would, a few years later, operate the satellites, but they always had responsibility for the data distribution and always sold the data. And I can tell you that even back in 1972, while I wasn't working in that part of the organization yet, there were people in Sioux Falls, South Dakota, which is where the satellite was, where the data distribution was handled at our Earth Resources and Observation and Science Center. It was called AROS. They were arguing right from the get-go, we need to be giving this data away, but didn't have the resources to give it away. Okay, there were a lot of costs that were associated with bringing the data down, creating Landsat scenes, and then distributing those scenes on, at that time, disks, floppy disks probably. So I want to be very clear that there was a vision, even back in 1972, to distribute the data. Over that entire history from Landsat 1 up until what you just said, 2008, the data was always sold for $500 a scene. When the U.S. government sold those Landsat scenes, in the middle of the program with Landsats 4 and 5, the government had actually transitioned it to the private sector, and the data increased by an order of magnitude. It went up to $4,000 or $5,000 a scene, and that almost killed the entire program because no one could afford to pay that kind of money for one Landsat scene. So then it transitioned back to the federal government about the time for Landsat 6, although that satellite ended up in the ocean, and then of course Landsat 7, Landsat 8, and I came into the picture about Landsat 7, where I had responsibility for that part of the program in the Geological Survey. So that's kind of the history, but it looked like you wanted to ask
No,
a
I just
question
wanted
about
to
that.
give some context. Like, what's the size of a scene of Landsat? You've been talking about scene, like, just to give some context.
Yeah, so that's another really important point, because we're going well beyond scenes and getting down to very, very small scales. So the resolution for Landsat data is on the order for black and white 15 meter up to about 15 feet to about 30 feet. And the scenes covered, actually, I should check this number, but say 100 square miles, something like that. So they were large areas, even though you could look down and see farm scale items, maybe not individual buildings at that scale, unless they were quite large. Yeah. So for Landsat 7, I got into the program in about the year 2000. Okay. Yeah, I served in that role from 2000 to 2008. And of course, coming into that division, I heard these stories, that we sold data. We looked at the statistics. We were selling about 53 scenes a day. So 53 Landsat scenes times 365 days a year. We were taking in about $4.5 or $5 million for the sale of that data, which is not inconsequential, to any federal agency. Particularly the size of the Geological Survey, $4.5 or $5 million is substantial. But I would argue we were asking the wrong question for a very long time. After you have invested hundreds of millions of dollars, in fact, billions of dollars from Landsat 1 up to Landsat 7, how could you justify the expense of that program by only selling 53 scenes a day? So we did we did a survey analysis. Who's buying those 53 scenes a day? Number one, other federal agencies. Number two, contractors who were largely working for the Defense Department. Number three, universities. And then some citizens. Okay. So other federal agencies with federal money were paying that $4.5 million to another federal agency. So what that means is you're taking money out of this pocket from the federal government perspective, you're putting it in this pocket, and you're incurring transaction costs at every step of the way, because we had to account for those sales. That other federal agency had to kind of put processes and procurements in order. It wasn't efficient. So we went back to Congress, actually starting in about 2000 when I got into the job, or 2001, once we had kind of gotten the analysis, and said, this isn't efficient for the federal government. We should, and at that time the technology had changed so that you no longer had to send a Landsat scene, out on a floppy disk. You could in fact distribute it over the internet. And so we went back to Congress first the Department of the Interior, and then the Office of Management and Budget, who works for the White House, and then Congress, and said, you know what, this isn't right. And it took many years to convince them. But what happened is what we predicted would happen, is that the usage, the distribution and usage of Landsat data, if you remove that constraint of selling the data, would just explode. And it did. We went from 53 scenes a day to 5,300 scenes a day. That's 2 orders of magnitude, right? And then later, I had left the organization at the time, but we did an economic analysis. The organization did an economic analysis in about 2011 that just showed it was a public policy change within the United States that returned an economic benefit of $1.7 billion to the U.S. government, $400,000 outside for Europe, here, China, wherever, across the world, South America, for a global total of $2.1 billion. That's pretty amazing.
Yeah, for a policy change.
For a policy change. And it far exceeded the $4.5 or $5 million that we were collecting for selling that data. So the rationale within the federal government was, and I would argue for any public sector institution around the world, whether it's a stream gauging organization, whether it's a weather service organization, whether it's a geological organization, whether it's a satellite operator, on the public side, citizens have paid for those organizations with their tax dollars. They've paid for those collection devices. They've paid for those distribution devices. And now you're going to charge them for the data? That's the cycle we want to break. Right. That data is the reason you built those collection devices. You didn't build it just to build a satellite or just to build a stream gauging network. You built it to deliver data about the Earth, and every taxpayer is entitled to that data. There's a different business model on the private sector side, and we can talk about that. But number one, governments owe it to their citizens for open data, open science, open services.
The field of open source intelligence got a lot of public attention in 2022 because of the war in Ukraine. So I wanted to understand a little bit more about how satellite images and just geospatial data had been used in that context. So I talked to Jeffrey Lewis, who is one of the prominent open source research intelligence people in the field, how he used that data, how they tell their stories. And one of the highlights of that conversation, in my opinion, is how him and his team were able to call the invasion of Ukraine just an hour before it happened.
The part where we call the invasion about an hour before it happens, that to me is a perfect example where...
Wait, you actually called the invasion an hour before? Sorry, I just realized,
Yeah, we put it on Twitter.
Oh, wow, I didn't realize that.
Oh, yeah. So let me tell you what happened. This is a funny story.
Yeah, sorry, please do. Sorry to interrupt, but I want to hear about that.
Okay, so a couple days before the invasion, maybe 2 days, maybe it was only 24 hours, we got an image that Capella took that showed a Russian armored unit. There were tanks and armored personnel carriers. And there were a lot of them. And they were lined up in columns along the road. And this was a huge change for us because all the other Russian armored units we saw were parked in different ways. They were all parked, basically the vehicles were in like a square. And it's how they camped. So you had the tents, you had some vehicles parked in squares, and they would sit there for, months. This was a unit that was clearly on the move, right? So everything was lined up in columns, and there were no tents. So we were like, oh my God, this is a unit. It is very close to the border. It looks like it's going to pounce. And the Biden people had said publicly that there were Russian units moving into attack positions. And they didn't say what that meant, but from looking at all the imagery, it was clear to us that's what this was, right? This was a unit that had not been there before, that had just shown up, and they had just shown up, and they were not planning on staying. We then came across a TikTok video. A colleague at a different at a new space company had actually found it and sent it to us, where someone drove by the unit. And so we were able to confirm all the identifications of the vehicles because we had a TikTok video of the unit plus a satellite image showing it's ready to pounce. And then, but then we're not going to get another image from Capella for like 24 hours if we're lucky. So we're just waiting around. And one of my colleagues has the great idea to check Google Maps. And it's like 5 o'clock in Monterey, which is about 3 a.m. local time. In Russia/Ukraine, because this is on the Russian side of the border. And suddenly my colleague John Ford is like, oh my God, there is a traffic jam right next to where that unit is stationed. And we're like, wait a second, it's 3 a.m. There should not be a traffic jam. And it was clear to us that what was happening was the vehicles were probably getting up on the highway, and they were probably preventing people with their phones from getting on the highway. So, right, that unreasonable assumption that we all have that you're going to get a minute-by-minute traffic update is true. You are getting this immediate update that, like, suddenly people can't get on the road. It's very funny because I'm like, holy crap, the invasion is starting. And all of my colleagues who are junior to me, a lot of them are graduate students, are like, do we really want to stick our neck out on this? So we sat there for like 5-10 minutes and watched the traffic jam slowly go down the highway toward the Ukrainian border. And finally, I'm like, we have to say something. And none of them wanted to do it, because I didn't want to like take credit. Like John's the one who found the thing. And John's like, I don't want any part of this. And so I'm like, fine, I'll do it. And so I put it on Twitter. And so we announced that unit was on the move maybe an hour before the first bombs fell. So I bought everybody pizza, and we just sort of sat in the office and just watched the war start.
That must be surreal to see it.
It was
happening,
totally
like,
surreal.
Live,
yeah,
on Google Maps.
Yep. Well, because it's a real-time, updating of traffic. But, people are like, oh, you could see it on Google Maps, but you wouldn't have known what it was without the satellite image.
Yeah.
And you wouldn't have known what that satellite image meant unless you'd seen all the other satellite images, right? You needed to know what a normal unit looked like in order to understand that this unit was not normal. It was about to go somewhere, which would then cause you to watch Google Maps and to notice when they had started. And so, it's not one piece of data. It's all of the data fitted together in a coherent picture. And by the way, the funny thing is, I don't know if you noticed, I can't prove this, but Google Maps a couple days later broke for like several hours. They have never said why it broke for several hours, but they later announced that they had updated the software to prevent Russian analysts from doing in Ukraine what we had done in Russia, which, like, good for them. Of course they should have done that, but I'm like slightly nervous that I broke Google Maps.
Satellite images and remote sensing is usually held as something that is going to solve many problems, from helping agricultures better predict the yields of their crops to being able to monitor deforestation. While the reality is usually a lot more complex, there is some room for these technologies to help us solve some of those problems. That's what I wanted to better understand, and part of this year I've had many conversations. This one is with Arjen Vrielink, the director at Satelligence, who I happened to work for a little while ago, about how remote sensing is helping prevent deforestation. But it's not the only thing, and it's definitely not a silver bullet. Stopping deforestation is the thing you want to do. Like, that's the mission. Why is Earth observation the tool that solves that problem?
It's the tool because we happen to work at a remote sensing company. So I must be honest, we started with it, we just discussed it, the classic solution looking for a problem, right? And then actually, so this remote sensing doesn't stop deforestation, but then we happen to work for a remote sensing company, and we happen to know a lot about forestry and land use and what people do in the tropical regions, commodity production, supply chains. So we knew a lot about these things, and then we tied some knots together, and something started to emerge. Together with the notion that if you look at the problem of deforestation, there's like the classical approach would be the governmental sector, so governments enforcing their laws to stop deforestation, but maybe the law are not strong enough, maybe the law enforcement is not strong enough, maybe there's some corruption. Apart from that, the political and governmental pace of frequency is glacial, like it's every 5 or 10 years when there's turnaround in new laws. Maybe there's the UN, World Bank, that kind of institutions, same problem. So lots of funding, very little executive power. And then on the other side, classically, there's the campaigning NGOs, the activists, who I see as putting, like they are one-issue parties. Basically, they're one-issue political parties, very executive and activistic, Greenpeace, Mighty Earth, WWF. So they put this on the agenda, but they are very polarizing and accusing.
Okay.
But that's their role. I mean, they create the political agenda. But the real driver, the real reason for the big deforestation, for example, in the 80s and 90s in Indonesia, is the commercial sector. So those are Northern Hemisphere consumer markets with associated manufacturing, retail, and trading companies that source from Southeast Asia. So if you want to tackle deforestation, maybe that's a good place to look. That's why we thought, okay, if we found Satelligence and give it a really commercial mission, because our premise is that you can't have a sustainable, or a company fighting for a sustainable goal without it being economically viable.
Yeah.
If you don't have an economic viable business model, there's no reason to be. So you don't even have a platform for your message. So that's a condition. And the other one, instead of fighting the enemy, why not join the enemy, so to say, and cooperate and engage with them and see how you can help them make a change. Because this is a personal conviction of me, is that companies don't exist. There's only people. So companies are abstractions.
Okay.
And there's Max across me. So I work with Cargill. Cargill isn't the most evil company in the world, but there's John and Hank from Cargill, who are the most wonderful persons you will ever meet. And they have zero evilness in them. Mm. So this is one of the things I think about a lot, like where's the tipping point? Where become 5 humans an organization, right?
Where does that happen? Like, how do you explain that shift then that happens, where there is this like very surreal thing that happens when you do meet people from these companies that you think are the most evil companies ever, and they're like wonderful people. Have you found a solution to that?
Yes, well, there's no solution, but I'm starting to be aware of why this happens. And this is, like I just described, the political governmental frequencies, like 4 or 5 year intervals. That's the pace of change. Yeah. Then if you look at companies, they have traditionally a 1 year pace, like a financial.
That's budgeting, right?
That's budgeting, and that's like they can change on that interval. If you look at fashion, that's maybe the fastest. It's twice a year. So there's a new fashion industry. If you look at cultures, maybe it's one generation of change, so maybe 20 to 30 years. So companies are ruled by the previous generation, right? But the work is done by the current generation. So the people you meet of companies are actually one generation behind the actual beliefs and cultural changes. So it takes one generation for a company culture to change. And this is also something, and this is why people perceive these companies as evil. It's the same as that, like if you smoked in the 70s and 80s, it wasn't seen as something bad.
Right.
Side anecdote, semantic stretching, like how words become, the meaning of words changes over time, like the word innovation. Innovation used to be a very neutral word, like in the 40s and 50s. Now it's a very positive word. It has a positive connotation. So if you do innovation, that's all we do, innovation. That's great. But then people don't realize cigarettes are also the result of innovation, right? But still it has a very positive connotation. End of the side action. This is also like how my brain works, very serendipity. How did we get here? Yeah, so the perception and perspective of people about themselves, but also about other people, like their social context and about their environment changes. And this change doesn't happen over time. Like you don't, like fashion, you just go to the store, buy the new fashion stuff and it changed. But these cultural changes just take longer to take part. And that's why you probably don't notice. But where you do notice is these like, oh, this company is evil. That's not evil. It's just what you're seeing is the cultural values of 30 years ago, which are perceived as evil now. So it takes a generation, because the people working at this company now, like your peers from your study, they will be the managers of like 20 years ahead.
Staying on the topic of vegetation monitoring, this year I also interviewed Indra den Bakker, who's the CEO and co-founder of Overstory, where I happen to be working, by the way, when I'm not working on the podcast, so just keep that in mind. Overstory is focused on wildfire prevention and just vegetation monitoring around electric utilities. And I wanted to understand a little bit more how Indra decided to focus specifically on that problem of everything else that satellite images could be helpful for, and what does it mean to use those images to solve that specific problem? How do we end up on utilities? And I want to explain like what utilities are, mostly because when I joined I had no idea what utilities are. So it's like companies who basically do the transportation of electricity between the place it's created. It's just like all the power lines that we see, the companies who operate all the power lines. So that's one of the biggest focus of what Overstory is doing today. How did we get to that focus?
Yeah, also a long journey and a lot of learnings in between, I guess. So I think it took 2 years to really start to focus on that. And I think the funny thing is, like, for us here in the Netherlands, we only have large transmission lines above ground, but all the distribution lines, so the smaller, lower voltage lines are underground. So it's not as common for us Dutch people to think about power lines and vegetation in general. But I think over that first 2 years of Overstory, we just try to, I think most important then is learning, right? Like I mean, like people always think you have product market fit early, but it takes a while to get there. And I think it was a lot of experimentation, trying new type of customers, learning from customers. And at a certain point, we just got a strong pull from these electric utilities and their problems. And the more we learned about it, that they're causing massive fires in California back then and also here in Southern Europe, the more we felt, the tech that we actually already have would be super valuable for them, and they're willing to pay a premium for it. And I think especially that large part, that they are willing to pay for it and act on it, was really important, because there's a lot of other markets like carbon offset markets, forest monitoring. But that's not the sweet spot for the very high resolution satellite images because it's still quite costly to acquire 30 centimeter, 50 centimeter satellite imagery. And I think what we learned about these utilities is they're flying helicopters or drones every day. So 30 centimeter, 50 centimeter resolution is relatively cost effective for them. And I think that's sort of a moment where we thought, okay, this is a market where you can grow fast, where the budgets are already there, and where there's a real problem. And it sounds like we got that moment in one go, but it was, I think, just over those 2 years, more data, experimentation and trying. But I think once we decided to focus on that, it became, every new customer we onboarded, it became more clear that this is product market fit, because you just get a strong pool.
Yeah, this is an interesting part about, like, it's not just the tech, but it's more on the business model, where on the higher res imagery, be it spatially or temporally, you can get a lot more insight, but it costs a lot more, especially given that a lot of programs that are at a lower resolution spatially, temporally, like Copernicus, like Landsat, are free.
Yeah.
So the cost of data is zero. It's just the compute that you're going to do on top of it. And so there's a huge step in cost if you want to go to high res. So like finding that business where there is a lot of that spending is going to be trickier.
Yeah, absolutely. I do think, like, because if you are only using public data, then you're even more competing on cost, because then the difference between you and another provider is the cost you put on top. Like the margin is just what you put on top of it. So I think that's where we wanted to stay a little bit away from. Like I know we spoke to other companies and they said, like, wow, we're the best in processing Sentinel images for forest. But the truth is, if you just used a little bit higher resolution satellite images, you don't need fancy algorithms. You can get higher accuracy than they get because you just have more in your image. There's a little bit of gray area, obviously, but I think, like, it's hard to create really something defensible on medium resolution satellite imagery. You just need to roll out that skill and do it very well, I think.
Right.
Where I think for more high resolution data, you can do that with medium resolution as well. But how do you combine different data sets? What do you do on top of it? The post-processing, pre-processing, you can gain more there and get even more insight. So yeah, I think you're right. Like, that delta in price should be worded to the customer. So it's really about the actionability as well. And there's a trade-off. So I think for probably majority of customers, Sentinel data would be good enough to build something actionable. But I think for our customer segment, that just doesn't work, because if you miss one single tree or 4 trees, those are often the trees that grow into the line or fall in the line and cause a fire, right? So for them, it's really about very detailed, but at the same time at scale.
If you've listened to any other conversations, you'll know one of the things I like to understand is how the money works. Where does it come from? How people make money? Where does the investment money come from? What are their interests? And this is something that I'm continuously trying to understand more about, because I think it's a crucial element of any business and of any endeavor. So I also talked to some people who helped me understand that this year. Jeff Crusey, who at the time worked at Seraphim Space, is one of the prominent investors in the space industry and also Earth observation. So he was a great person to ask a very seemingly simple question of how does investing work? And specifically, he's a venture capitalist. So that's what he'll be talking about applied to Earth observation.
Could you explain me in like a higher level overview what the role of a venture capital is and how investing works? This is probably a really large question, but I'd like to start there, and then we can start expanding on Earth observation space. But let's start with what investing is, how it works, and we can move on from there.
Sure. So I will describe what venture capital investing is, not to be confused with private equity or hedge fund investing. So
that sounds great.
And that's because I'm a venture capital investor. So typically what characterizes a venture capital investor is somebody that invests in early stage companies. So companies that are young, recently founded, and are looking for funding and selling minority equity positions in their companies to get that funding, using it then to expand their business and grow it. And eventually, hopefully, they take enough money to expand and grow their business to a point that it could be sold or go public at a value much higher than the original investment.
And so the minor equity is like a part of the company, right?
Right. So the reason I pointed out minority equity is venture capital investors don't acquire a company outright. They take less than 50% of the company on an individual investor basis.
Right. And so you buy that, let's go on like 10%. You buy 10% at the valuation of an early stage company. That's where they need like upfront capital. And then with the expectation that if they go public, that 10% is worth a lot more by that. Is that correct?
Right. Exactly. So, somebody might have an idea for a brand new toothbrush, but they need $1 million to hire people to help them design it and manufacture it. So they'll go out to venture capitalists. They'll say, I need $1 million. I will give you X percent of my company for that $1 million. So that tells them what a share price is, and then they can buy those shares. And then with that $1 million, hopefully maybe they'll generate, $10 million in toothbrush sales. And so that's valuable to somebody else at some point. So maybe a Procter & Gamble will come acquire that company, and they'll say, hey, you have 10 million in revenue. These companies usually get 2 times the revenue. We'll buy your company from you for 20 million. And so that is some multiple, whatever the original valuation of the company was.
So you mentioned early stage companies. What does early stage mean, and why is that important that they're early stage?
It's important that it's early stage because one thing that VC investors are looking for in their investments is a risk-reward profile that justifies their investment. And typically, when you have a relationship. The higher the risk, the higher the return potential is. Typically, if you're doing your job right. So the reason they're looking at early stage, to answer your question, is because that is where you'll see the larger growth rates occur than if a company is more established. It won't grow as quickly. So, and that's really what that growth rate, that hockey, like you'll hear referred to as hockey stick growth. That's really what VCs are looking for, and why they have to look at early stage companies, because that risk reward profile that they need really exists at the earlier stages. But there are different flavors of VCs too. So there's VCs that focus on the earliest of stages, and then there's VCs that focus on sort of the later stages of startup, of the startup life cycle.
Can you also, I'm sorry, I'm asking a lot of these simple questions, but I want to build up on them later on. What does early stage compared to late stage mean?
So early stage typically refers to the maturity of the companies. So an early stage company might not have raised any funding yet. They might only have 3 founders. If they're lucky, they got a prototype and a business plan that they've mapped out that they think they can build on. And then they might go raise a pre-seed round of funding from friends and family. That might be in the hundreds of thousands of euros or dollars. And then they'll take that, maybe they'll build a better prototype or a minimal viable product. Maybe they have some early customers, and they'll go back out to the VCs, raise a little bit more to continue to expand the company, and so on and so forth. So you'll actually see a lot of companies raise, 2, 3, 4 rounds of funding before anything like an exit, whether it's an IPO or an acquisition.
Continuing on that trend, I wanted to understand a little bit more the investor's point of view for some of the huge companies that require a lot of money to be able to build satellite constellations. What is in it for investors, and how do they see those industries? So I talked to Mo Islam, who happens to be the co-founder of Payload, a newsletter and media company, but who has a background in investing, on his take about why investors don't quite understand the Earth observation market just yet.
I think from an investment perspective, EO has been very tough. And I'm
Okay.
not saying anything controversial, right? You can just
No,
look
no,
at the
no, no.
stock prices of a lot of companies, right? I think
Well, a lot of the valuation went down after they went public. Like, just
yes,
to paint a broad stroke, like, this is what is going on in the industry. A lot
correct.
of the companies went public a year or two ago, and pretty much all of them went down.
Well, yeah, exactly. And we can let's kind of let's try to paint a little bit of a balanced view, right? So I think
Sure.
I think that you know, here's sort of like the overarching, like, interesting kind of like trend that has led us here today, right? What satellites that used to cost hundreds of millions of dollars that's not the case anymore, right? Hardware has effectively been commoditized. Lower cost of launch means new companies can establish constellations at significantly lower capital costs. That also means lower prices and an ability to expand the market, take more market share, and then still potentially generate reasonable unit economics, right? The downside of all this is that, low cost drivers and this type of feedback loop could also mean a race to the bottom, but we can talk about that in a second. I think the overarching negative from an investment perspective is that you have companies like Maxar and Airbus that have historically been the key players, right, in this industry, in this market. Now, because of venture capital and because of sort of the surge that we've seen in venture capital, we've seen a huge proliferation of competition in that space. You have the Planet, like Satellogic, Spire, Capella, Black Sky, et cetera, et cetera, et cetera, right? Many of these companies are collecting effectively the same data sets, but with differentiation that comes from maybe different levels of precision or frequency, right? Effectively. I'm very, by the way, I'm obviously oversimplifying. I'm sure if any of these companies were in the room, like I would get things thrown at me.
But they're more, what I think you're trying to say is they're incremental increases on top of each other. No
Correct.
one is coming like, we're imaging the Earth every single day, and we never had that before. It's like, we had every 2 days, and now we're doing every day, or we had a meter, and now we're doing 50 centimeters. It's like this incremental increase.
Yes, exactly. And by the way, there are some unique data sets that are being collected. I think like Spire on the RF side and Hawkeye 360, that I think there is some comparative differentiation that you can talk about. But either you're continuously iterating and making your data product, which in and of itself has an upper bound, right? From a market demand perspective, like you could it's like, hey, we'll make this optical imagery, just to give an example, like 30 centimeters. Now it's 10 centimeters. Now maybe one day it's 5 centimeters, right? Like, let's just say at some point someone's gonna be like, oh, I don't need it that. I don't need it that good. Like, I just don't. Like, that's really great and that's awesome, but I don't need it that. So you have this sort of upper bound from a market demand perspective. Or what you've seen is those companies now expand into other verticals. So like you saw this in launch, right? Launch companies are now not just launch companies. They're building satellites. They're building constellations. They're providing specialized components and equipment, right? Like, when you see that happening, typically what it means, when you see businesses go beyond their core product, what that typically means is like, hey, this core product is not that big of a market. It's not as big of a market as we thought it was. Right. Now I'm generalizing. That's not always the case, but sometimes, like a lot of the time, that is the case. And I think we saw that in launch, and I think you're starting to see that in EO as well. Like, you see a lot of companies are like, hey, the raw data side of things is not that big of a market. So we now need to expand into other verticals, platform, analytics, et cetera. And by the way, here's something I think about, and I'm actually curious to get your opinion on this, Max, because I know you know more about this than I do. But if you think about it like this, Maxar is the effective leader in traditional imagery, right? I mean, like, for all intents and purposes, right? They've been around for over a decades. They have these significant customer relationships, and the company does $1 billion in annual Earth intelligence revenue, roughly about $1 billion. And they have been around forever. So to build a profitable business, you have to assume a couple different things. You have to assume that the market expands, right? Or you see new business models or much leaner kind of cost structures, right? Generally speaking, like that needs to happen. So to me, like the positive, like now just to be kind of, just to think about that side of things, the big positive is that there's a variety of new business models that are now viable and interesting, like subscription kind of data offerings, whether it's like a one for all model that Planet's exploring, because Planet does tasking, right? But they also have been doing this thing where it's like, well, we're going to map the Earth every day. And we're going to provide that data. It's going to be like pretty much no added cost for us to add more and more customers to that like layer of data, right? So there's that side of things, which from a model perspective and like margin perspective is really interesting. And then you have companies who are obviously exploring SaaS-like models, and they're trying to target software margins or sell raw data at cost and potentially maybe use channel partners for analytics. I actually think that to me is the more interesting, like the Shopify model, like build the platform and then find channel partners to sell your analytics. Because like the other thing is EO companies don't know how big these markets are, these verticals are. Like you don't know how big this like whatever like like crop monitoring market is. Like now it's big. That's a bad example, but there are plenty of examples where like there are interesting markets, but you don't know how big it is. You don't know how much you need to invest in it. So use a channel partner and use your data and like get the analytics that way. So to me, the right business model is some sort of differentiated product via either superior imagery quality and effectively like a lower OpEx structure.
Moving a little bit away from the finance, but staying on things I don't understand very much about, but want to know more, is the legal aspect. Earth observation satellite images provides a wealth of data that can be used for so many applications, but the legal aspect is relatively tricky. So this year I also had a conversation with Kevin Pomfret, who's one of the prominent figures in the legal aspect regarding anything geospatial. And we talked about the nuances and why it was so hard to apply some of the current legal frameworks to some of the geospatial developments.
My concern is that lawmakers, policymakers, regulators don't understand the nuances of location data, all the different ways it can be collected, all the different ways it can be used. They're not technical folks. They may have some technical folks in there, but they don't understand this as well as this community does. And there's also a standard approach that the privacy community and lawmakers take in terms of it's something called the Fair Information Principles about how you develop privacy laws and what you require notice and consent and various rights that are really difficult in a location context because of the different ways the location is collected, because you don't have that one-on-one experience. So I often talk about, health information is very, very sensitive, right? Like the medical information, very, very sensitive. But we don't share that with everyone around the world, right? That's not being collected on us on a regular basis. So it's a one-on-one with your doctor or your hospital or a finite number of people. But our location information is collected in a lot of different ways and from different applications and used by different people, some for good, some for bad. But trying to apply something that was developed around health information to location information, which is frankly a bill that there's a bill in the U.S. Congress right now that would do that, raises a lot of issues, an awful lot of issues for this community, depending on how you define location information or depending on how people in their everyday work think about it.
Could you help me understand a little bit, like what are some of the issues that we're talking? Like, do you maybe have any examples or things to help myself and probably some of the listeners understand as well? Because this, especially myself, I'm quite technical, so things I try to see things through a technical lens, but I'm having a hard time sometimes understanding like what is the nature of the issues that we're talking about. Is it like some applications that just legally are not allowed to continue, for example, or are we talking about something completely different?
I think there is a possibility of that. So, but I think it's a small. Again, I mean, it depends on the geospatial community, and location data is so broad that there probably will be certain things that will be difficult to do, if not illegal, in certain countries or in certain regions because of concerns around location privacy. The broader risk that I see is one, if you need to get consent from an individual to use their location information, but you don't collect it, like I said, in a one-on-one transaction, like through a website, or through a a relationship with your doctor. If you're just collecting location information, how do you get that consent? How do they if they have a right to ask you to delete that information? How do they do that? How do you even know that you have it? Because that's one of the things you're supposed to do, is you're supposed to make sure that you identify all the data that you have about an individual. For instance, in GDPR. So if, depending on how you define it in GDPR, an individual has a right to say, what information do you have about them?
Predicting the weather is probably the biggest current application of satellite data. And I'm very pleased to have been able to talk to Andrew Blum, the author of The Weather Machine, which in my opinion is one of the best books explaining how we predict the weather, going from gathering the data to making the models that forecasts it. At the end of that conversation with Andrew Blum, we talked about something he alludes to at the end of his book as well, which is the privatization of weather forecasting, moving away from large governmental public programs to private companies who both provide data and the models for weather forecasting. Andrew has been a little bit critical about that and just warning about it a little bit. He wrote the book in 2019, so I wanted to take a look back on the evolution of that with him.
You closed the book as well saying that there's a bit of a crisis with private companies.
And that was 3 years ago. Yeah, I was too early in many ways with that.
So you see where I'm coming with this, right?
Yeah.
What's the situation now, and like, how do you feel about? Are you keeping an eye on like the developments as well?
Not as much as I should. I should be keeping a closer eye on it. I certainly there was, as with many things in the U.S. During the Trump years, there was a sense of crisis that the carefully assembled and sort of tended infrastructure was being deliberately dismantled. That with quite clear, that was quite explicitly the case. At least in 2019, where the NOAA, the government, U.S. government sort of weather agency, parent agency, was quite clear in wanting to privatize as much as possible. That was a sort of ideological stance. As with a lot of Trump things, the kind of tearing down, they weren't very successful at. It only went so far, is my impression. And then it also, with weather at least, it sort of illuminated some perhaps necessary technological transitions. To talk really specifically about the U.S. weather models, the tradition had been that the National Weather Service buys a supercomputer from IBM or from someone else, and they pay a couple dozen millions to have that piece of hardware installed, and that's the government procurement process that sort of takes this privately built thing and makes it a public thing. So while at first pass, the idea of putting the weather models in the cloud, sending them to Google, or sending the weather models to Amazon or IBM would seem like a sort of privatization of it. That's not really fair. It's a technological shift. But it kind of depends, but arguably it does that sort of virtualization of it, that sort of one step removal of the people from putting one step between the people who write the models and the machine itself, then removes, it makes it even harder to understand, even for the people who run it. And we become even more disconnected from the technology, even the people who are building it. And that is obviously, that sort of disambiguation is a huge it's a broader trend in so much technology. And there's reason to be a little bit nervous about that with something as complex and sort of critical as the internet.
One of the things I try to understand in the world of geospatial and satellite images and just location data is understanding what are the available tools that people can use, what are the trade-offs and benefits for people, and trying to make that just a little bit more clear, seeing through some of the marketing talk and helping understand that. I talked this year with Alemohammad, which at the time had just left the Radiant Earth Foundation, which is a nonprofit that is focused around developing a community of machine learning practitioners around Earth observation. And he had a pretty good explanation of what the difference was between Google Earth Engine, Microsoft's Planetary computer, and then AWS is offering and how what the Radiant Earth Foundation kind of fits into all of that.
There's been a sort of rise of different platforms of trying to be the geospatial data platform. Microsoft building their Planetary computer. AWS has the Open Data Registry, where there's a lot of data sets. Google has Google Earth Engine. There's all these big tech companies trying to do that. Isn't the ML Hub competing in a way with those? And so if not, like, how does that position? What's their interest in supporting this effort? I'm playing devil's advocate here a little bit.
No, it's a good question, and I think that we should discuss in the community. Let me comment on one thing and then say how we are not competing with them. First of all, those three that you name have very different solutions. So AWS Open Data Registry, which is also supporting our data store on AWS, it's only a data store. So it says, this is an S3 bucket, this is the data there, and this is the entry on the website, potentially a contact, some tutorials if the data provider is providing them. They stop at there. There is no compute solution, right? There's no integration with a server that you can consume the data. You need to build your own either an EC2 VM or getting the data out to your server.
But it's built on top of AWS infrastructure still.
It is built, yes. It is built on AWS. So it is easier for you if you go to an EC2 machine, which is the basically virtual machine on AWS, spin it up, use that data there. It is faster, easier to do that. So that's AWS. Microsoft Planetary Computer, as the name says, it is actually a computer. So you have hosted Jupyter Notebook servers that you can easily go there. It's already installed. You don't need to do any installation. You just log in with your account. You have a Jupyter server running, and you can start hitting their API, which is basically the same type of data you might find on the AWS Open Data Registry in terms of geospatial data, because the AWS one is broader than geospatial. And it uses all of the open source technology, including Stack and Pangeo in terms of its structure, and you can start building solutions. You don't need to think about your infrastructure at that point, unless you have higher demand for the number of CPUs or GPUs or RAM or disk space or things like that. Then you need to spin up your kind of customized virtual machine on Azure. So they go a step further than AWS in terms of solution. Google Earth Engine, on the other hand, so they are the first one in terms of providing geospatial data on a cloud, if you call it. It is different in the sense that the data that you access, it is not, to my interpretation, raw data, because they catalog the data, they store the data in a specific Google Earth Engine format, and they have a very good interface. So that's what they do best. That many people who are not necessarily a software engineer or a data scientist, but they're a researcher with some basic knowledge of programming, they can go to an interface, which is the code editor on Google Earth Engine, and start literally with a couple of lines of code, do an analysis, do a visualization on top of that. So that visualization is also a significant benefit there, and potentially run global scale analysis, but with the caveat that the resources are basically limited. So you need to sometimes wait for a global analysis, for example, because it's
a bit more of a walled garden, like bringing things out.
It's walled garden, yes. Yeah, taking things out, it is not easy. And it is designed for people to work in that ecosystem. Because it was launched about 10 years ago, it is not much I would call ML friendly. ML in terms of particularly deep learning. Yeah, you can do like random forest or typical classification problems there. But if you want to train a CNN model, a convolutional neural network, you can't do that in GE. You should take the data out into Google Cloud, train it there, and then put the model on the Google AI platform, and then hit that in the Google Earth Engine to get the model to run it in Google Earth. So there's a lot of complexity in there. Recently, they talked about connection between Google Earth Engine and BigQuery. So I think something is happening. I haven't looked into that. So hopefully new advancements will come in.
This year, I also talked to a couple experts around the topic of food security and how satellite imagery and just geospatial can help in that endeavor. First, here's an excerpt from a conversation with Catherine Nakalembe, who is NASA's Harvest Africa program director, about how food security is not just about having food available for people, there's a lot more that comes into that, and remote sensing, again, isn't a silver bullet.
What is food security? It's basically that people have access to food all the time and high quality food. So it has these broad components which include access, quality, quantity. And when you think about access, it also it integrates things like, if there's food at Whole Foods, but I can't buy it because it's so expensive, I don't have access to it.
Right.
Yeah. So like they have to be able to afford it. Affordability is one of those things. Just one of a good example that could demonstrate food insecurity is the place that I studied for my PhD. So Uganda as a country is not food insecure because it's one of the in broader region, it's like one of the countries that performs really well in terms of agricultural productivity. But this one area, which faces more extreme climatic conditions, so very dry or floods all the time, crops fail often, is one that is food insecure. And so one way that you would try to resolve this would be to improve accessibility, which is bring food, just like there are deserts in the US that are not actually food deserts, right? So you would make the food available in Karamoja through, it could be just improving transportation routes and stuff like that. But to add to the mix of the level of insecurity is that the food in the region that's brought to the market is so expensive that even though it is there, it's just prohibitive. Like local people can't actually buy it, and they don't have the money to buy it. So that's part of being food insecure.
So it seems like remote sensing would be like a small part of that much bigger puzzle of trying to figure out the whole situation and evaluating all the different options that you have.
In terms of food security, some of the things, in terms of food security, so in order to understand access, you have to understand agricultural production. So agricultural production is where like remote sensing has a huge contribution. So from very basic things like what crops are growing where, this will give you an indication of production. So we could generate like crop type maps, for example. From those crop type maps, the other thing satellite data allows us to do is looking at conditions. So now we know there is like sweet potato in this region. How is that sweet potato performing compared to, other areas, but as well as in time. So if we know that, and now I'm talking about, purely if you think about like vegetation condition or crop condition, we're comparing now to last year or the year before. So we know this is what the average condition is for a good yield. If it's below that, it might not be. The other is we're looking at rainfall, temperature. All of these data sets exist. So we can forecast. We can look at now. We can forecast what the outcome might be. And the other is, there are so many things that you can look at. If you're thinking about accessibility in terms of infrastructure, too much rainfall is not good. Too little rainfall is not good for production. Too much rainfall could easily cut off an entire region, so people can't be accessed. So you can kind of, make those, you can think about those things. Going towards yield forecasting and modeling, like if we can understand what average production is in a region, we can kind of like predict what it will be for a specific season. And then from that, you can then model all of these other things like accessibility. And it's really interesting. And there's not a lot of work going in this other particular space, but like looking at the quality of food, there is definitely opportunities there to look at. It's not purely about, it's not purely about there being more. In the end, it's about more of what and for what. So we could be looking at, let's say, soybean in Brazil or corn in Brazil, but it's being produced for either fuel or to be exported for feed. And so that doesn't actually solve the food security situation for the local community. It's just basically being exported. It's not being used for local consumption. And so if all the vegetation is doing great, but it's just corn for export, that is not addressing food security. So there's like all these other dimensions that a basic product like crop type would be relevant for example. And then of course there's looking at like agricultural practices, mixed cropping, looking at cover cropping that could help improve like policies around protecting soils. Ultimately, eating now should not compromise eating in the future. So if we wipe out the soils in the process of feeding people now, that's not a very sustainable food security scenario going forward.
Finally, for this wrap-up of the year, I want to bring you this clip from a conversation I had with Jean-Martin Bauer, who is the country director for Haiti's World Food Program. He's been very critical about how remote sensing and just data can be used for humanitarian aid and how tricky that can be. We had a pretty broad conversation about all of that, but I specifically wanted to highlight how in a place like Haiti, knowing that there is food insecurity isn't really getting anywhere. You need to dig a little bit more, and I wanted to understand that with him a bit better. How do you know the food situation in a country? I was looking at, there's a hunger map that's done by WFP, and I was looking at Haiti just before the recording, and you go on there and it's like red. It's the whole most of the country, there's food insecurity, and the question that pops to my mind is, how do we know that? How do you assess the situation?
To be honest, you don't need the hunger map to tell you that there's a problem in Haiti. It's well known, but the hunger map helps you be a little bit more deliberate with the questions you ask. And food insecurity is a very abstract term, and it's made up of different components. And I think we've had assumptions about food security historically. This is, when I say we, this is the food security community. And I think some of those assumptions have not always been true. So we assume that things about food production, for example, that lack of food production equals food insecurity, which isn't the case. And we've made mistakes in the past in terms of what type of response option is appropriate for specific context.
Could you expand on that a little bit?
Well, look, and this is in the 1960s. There was a lot of international in-kind food aid. You come in with boats of food when, in fact, what's really needed is a cash transfer would probably have been the best thing to do. And but again, I mean, an agency like WFP is able to do both and does analyze things quite thoroughly. And and in fact, Max, this is where it matters. So if you do your analysis well, you're able to zoom in on those factors so that the best decisions are made. So I think what's not, well, it is interesting to know whether a country is in trouble or not, and where they are on that scale. Is it a yellow, an orange, or a red, or for specific areas, is it a yellow, an orange, or a red, or even a green? But it's also why. I mean, what's going on? Is it because of conflict? What's the role of climate in it? How are the markets doing? That's what's really interesting about food security analysis, is that these factors keep changing. I mean, I've been amazed in my career as a food security analyst to see that sometimes things just flip on a dime. I mean, in just a few weeks, the situation totally changes. I think you had that with the war in Ukraine. I mean, the situation was not very good. The global food security situation wasn't very good, with high food prices and food inflation already in early 22. But as soon as that war started, we faced a very new and painful reality worldwide. So food security analysis also has to be flexible enough to capture these dynamic events. A country like Haiti, for instance, relies on imports for 80% of the rice that's consumed. I think the majority of food that's eaten in Haiti is actually imported by value. And something like the war in Ukraine is a huge risk for countries with an import with dependency on imports. So And that's also true if you look at the country itself and what's going on in the north and the south of the different different parts of the country. They'll have a specific profile, and you need to get acquainted with those. With food security, as in very many other areas of humanitarian practice, one size does not fit all. You need to be able to get acquainted with the communities and the different contexts in which an agency might operate to get things right. Might be okay to have more of a macro approach in a fast-breaking emergency, but to really get things right, you need the data, you need to understand the problem, you need to disaggregate it, and hopefully the agency and its partners are flexible enough to have the response that's just right for that environment.
I had many more conversations this year. I hope either if you're new or you skipped a few episodes, you found this useful. I myself had forgotten some of the interesting conversations I've had, so this serves as a great reminder. I'll have, of course, the links to all these conversations in the show notes. I invite you to go look around. I have timestamps in all the episodes, so you can also jump around. I am very excited for what is coming up next year. I hope you had a great 2022 and look forward for 2023. I thank all my guests, usually at the end of conversations, for spending some of their valuable time with me and having conversations, and I want to extend that thank to the people listening as well. These conversations are long, they are usually deep, and I know they take a lot of time to also listen to, so if you've been listening to or are just discovering, I want to thank you for your time, and I hope you find these conversations interesting and insightful. I'll see you in 2023. Cheers.